Hello, today I'm gonna explain my BNA file. We're currently inside it. Um, I do not have my IDE on this machine, so I'm gonna do it with Notepad++, just so you can see what's inside. So we just opened our permissions file. Our permissions files contain some information about uh, who can do what on the blockchain. So you can see here, there's the rule, validate new batch. Well, who can validate a new batch? The steering group, or which is class called validator, and he can read and delete. Write is also in here. It's not needed to explain that in the operation. Read and write are basically the same. Okay, so after that we're gonna go to our model file. Our model file contains all of our classes inside the blockchain. So you have your badge class, which is just a badge. It has a name, it has an image URL, description, criteria, an issuer ID, so what organization gave the badge, a teacher ID, who issued the badge, and a validator ID, who validated the badge. It's set to optional, because when you create a badge you don't know who's going to validate it, so it can be left empty. And there's a boolean validated, and its default is false. So when a badge get issued, it's transformed into an issued badge class, because the badge class is basically a blueprint for the issued badge class. So the issued badge class has a badge class ID, which refers to this asset, and it also has a teacher ID, an issuer ID, evidence, validator ID, which is also optional, a validated boolean, and an integer of how many times it is rejected. So this way an issued badge class can get all the information from the badge class, which is the image, description, and criteria. So after that, we're gonna go to our participant. Let's see. We have a participant called base user, which is abstract, which means that it's not really a participant, but it can be extended with other participants. So base user has an entity ID, a first name, and a last name, and is identified by his identity ID. After that you have your badge user, which extends base user, so it has all these three fields in it. He has his own password, email, and a role. A badge user is basically a student that receives badges. You have your issuer that can give badges to students, and they also and you have your teacher. Oh, I'm sorry. An issuer is the organization, and you have a teacher that can issue badges, which also extends base user, and a validator, which also extends base user. Pretty standard stuff in here: the password, email, role, for both of them. You have a transaction, so you also need to create your transactions in here, the blueprints, which is called new badge. With that you send an entity ID, a name, an image URL, a description, criteria, issuer ID, and teacher ID. So the basic thing is, when you submit a transaction that from new badge, you create a new badge class. The reason for that is why you use transaction to create a new badge is because you can actually perform some actions on it, and when you just create a new participant you cannot. We also have transaction that validates a badge. It's pretty simple on what it does. It has a validator ID, a boolean if it's actually validated, and the new badge ID. The same goes for issue badge and validate issue badge. So now we're gonna take a look at our actual transactions. So as you can see, I have some transactions here. Let's see, where do I start? So I'll start at create badge. Well, first it just logs it. That was for ourselves. After that you return the edit registry badge class. this looks kind of weird, but you need to do return here because you also return it in here. So this code gets executed first. We use our factory and so the way you create assets in Hyperledger is that you use a factory. After that we call batch, it's a variable, and after that you use your factory new resource. You say, okay, where is it, in what space, and you say batch class, so the blockchain actually knows that it needs to use batch class, and after that you give the identity that was sent in from the front end. Also a little fun fact about that: the front end needs to be generating the IDs, because on a blockchain you have different nodes running the code at around the same time, and the problem with that is that the result always needs to be the same. And if you have multiple nodes running, the ID can differ, and that won't work. It will just get rejected. So the front end needs to give an ID. After that you have your batch name. It's all speaks for itself. It's just a transaction, and it sets certain values that you gave with the transaction with the TX, and you give it to the batch. And at the end you return a batch after you added it to the registry. So when you create a new batch, then it needs to be validated. And this works a little bit different. If you remember, we used a factory here to create a new resource. In validate new batch, you don't create a new resource, but you need to edit one that already exists. So for that you use a registry. The await here is pretty essential, otherwise it will not work. You have your var batch, and you say await registry get tx new batch. Tx transaction, and the new batch ID is the one you send in with the transaction. Then the batch validator ID will be equal to the transaction validator ID. The same goes for validated. And you update the registry. Let's see, then you have your issue batch. The issue batch, it's quite the same as create batch, except here you use a batch class, and for an issue batch you use an issued batch class. So it's quite the same as create batch, and after that you of course have the validate issued batch. As you can see, it's not that different from validate new batch, except for this little part with where it adds 1 to the rejections whenever it is rejected. So what I wanted to show you else is this part. It's the package.json. So it's basically one big string with a lot of settings for the patch, for the package. So it has your name, the author, some other pieces. Let me check where and right here you can see the version. It's 0.13 deploy 61. So that was my video explaining the blockchain Hyperledger BNA file.